Any other questions? Any other questions? No? Okay. So everything else is clear? All right, so this is what I'm going to do today. I will go over your homework, hands-on questions quickly. And then after that, we will learn additional DDL, data definition language, to manipulate different kinds of database objects. So first of all, let me open up the question for your homework. I think, so this is the slide I have not put up yet because I don't want to confuse you. So we have not finished this last slide yet, but today's slide, I'm going to just show you that this is the homework question I'm going to review. Okay, can everybody see that screen here? So here we have like three entities: professor, class, and student, right? And there's a one-to-many relationship or many-to-many relationship. So we are going to create we first of all have to convert it into relational model, and then we write SQL to implement that, right? So first of all, let me use my whiteboard to show what this relational model looks like. It should be so this question should be very simple. Okay. So you're going to create tables as follows. So let me put on this side here. Yeah. Oh. Okay. So you're going to have a table, professors. That table is going to have professor ID, instructor ID, that is part of UID primary key. And then you're going to have a last name, first name, which is all like optional. Okay. And then we have department. It's also optional. And then you have phone and email. And they're all optional. And then let's do the next table, classes. Classes as course number, and then section number. So in this case, both of them, both course number and the section number, form a composite key, primary key. And then title, and then credits. Both of them are optional. And the last table, students, let's put it here. And that has student ID, last name, first name, major, last name, first name, first name. Those are optional. Major, optional. And then finally, birth date. Birth date, which is also optional. All right, so this is a very simple process. Just follow the rule number 1. And now let's do relationship. So let's handle this one-to-many relationship first. So because of that, I need to duplicate primary key of professors into classes, right? And also that foreign key should be required because this, you'll see there's a solid line here. I hope that by this point, everyone should be clear on this, all right? And if not, then you're going to have trouble next week during your first exam. Your first exam will be, I plan to do it on Wednesday, okay? And on Monday, I can leave that day for you to ask questions. Just you have, during the review, you have something you do not understand. You still need to have, clarify some confusions. So Monday, I will give you the day off, just ask questions, okay? So Monday, we could just do it online, okay? So next Monday, we just do it online. So just do review, okay? And then for Wednesday, we're going to do exam, and exam will be all online because this room is not enough to handle everybody, right? So we'll just do everything online, okay? Then Friday we'll be just we'll review your exam, okay? And no Friday, sorry, no Friday anymore. So we changed that. So just Wednesday. So Monday we're going to review, and Friday and Wednesday we'll do the exam online. Okay, is that clear, everyone? For next week. So make sure at this point you know how to convert ERDs into relational model, because if I ask you to draw ERDs, you may not get a perfect answer. But for this kind of questions, you can easily get a perfect answer, right? You should not lose points on those, one to many, many to many, those kind of things, right? So I suggest that you make everything, put effort on that to make sure you understand. So now let's say, because the professor and the classes has a one-to-many relationship, one side is professor, many side is, my screen is flickering. Why? What happens? So let's say professor is one side, class is many sides. So you're going to duplicate primary key from one side to many side. And also look at the foreign key receiving side is classes, so that is solid. So then you're going to make that a foreign key as required also. So I will make that as, we can just call that a professor. Okay? So that is a foreign key, and that is required, and that is duplicating from, cannot do this one. Why? Okay, so that is how the connection is made. And then we have many-to-many relationship. So for that, we are going to create a junction table in the middle. So we are going to create a junction table. So first of all, in the junction table, I will have to have a student ID duplicated. Student ID. And in junction table, remember all foreign keys are required. So you do not need to, do not be confused with this optional to optional here. So whenever you have a many-to-many relationship, you create a junction table, and in the junction table, all foreign keys will be required. Okay, and that is a foreign key from student. And then you also need duplicate primary key from classes. Remember, classes has 2 columns as one foreign key, so you need to duplicate both. So you're going to have course number and the section number, and of course they will be also required. Okay, and then who can tell me how many foreign keys does this table have? No, just 2, because this actually together as a 1 foreign key, because you duplicated 1 primary key. Okay, so that 1 primary key duplicated is going to be called 1 foreign key, right? So if you want to make connections, then this is going to be connected here, and other one is connecting to class. So it's not very easy to draw in that case. So basically, you can just say like that. Okay. Okay, so that is a relational model. So now let's try to implement. Okay. So we'll write SQL statements to implement this. Any questions so far from people online? Good. Just make sure you stop me if you get lost, okay, or you are behind. I just this last couple actually weekends I did quite a few WebEx meetings with some of you, and I found that there are some basics. Some students still don't get it, but I just don't know why you don't stop me during the meeting, during the class. All right, any questions? If not, let's go to log on to Oracle. So make sure you know how to log on at this point, right? So I'm going to create those tables in here in SQL Developer. So we're going to create table without foreign keys first. So professor's table definitely would be the first one to create. Okay, and to move this away. So let me make this looks clearer. All right, so this is the better, right? So let's say create table. Is that clear? The word is the word recognizable or too small? Let me see whether I can make it bigger. Let's see. Tools, preferences, and see. There's some kind of a code editor right here. Okay. And then fonts, let's change a bigger font. Let's make it to like a 15. Hopefully that's big enough. Great. Still not good enough. Do it again. It's number to 18. Hopefully that's big. Yeah, that's big. Create table. Professors. Good, parentheses. And then we have IID. So say that IID, I'm going to use a number, maybe like a 3 letters number, 3 digits. So that will allow you to have up to like 999 professors. Okay. And then, so this one, let's just say is not null. So because we are going to make that as a primary key, so it's not null by default. And then last name, child, so that's 45 characters. And that is null, so we'll just leave it by default empty. And then first name, child, 45, also by default. Department. So department here is going to be something like department name, maybe, right? So if we have another entity called department, then it's going to have a department number, department name, department location, all that. So then this probably will be just like a foreign attribute. But here, I assuming that we just have a department name. So let's say child 25, also not null. Form, and then say child 14, and then email, child, let's say 50 letters. Okay, so that's all list of all columns. Now let's do constraints. So obviously we need to define primary keys, right? So constraint, PK, and then let's just say professor, and then content of a primary key is, content of constraint is a primary key. We need to say ID is primary key. ID, okay? Are we going to have any other constraints? We could. So let's just say for department, let's say we have only list of departments. Okay, like accounting, management, marketing. Okay, so let's just try to create another constraint, which is not in the original model. Okay, but just show you that we can do that. We can do that later. Later. So we'll just show you how we're going to what is the homework answer first. Okay, so let's say we have that first table created, and now let's create a table. We can do for the classes next, because primary key, foreign key for classes is a professor. We already have that. So we can create next table. So let's move this up first. Okay. Create table, classes, okay. Parentheses. So they'll have a course number, course number. Let's just use a char because that one may have like a dash, like a universal background. We have 6500 colon something, right? So I will make it 8 characters for that. Okay, and then that's not null. And then section number. Section number is just number. So typically like a 1, 2, 3, section 1, section 2, and then maybe 801, 802. So I'm going to use 3 digits for that, and also not null. Okay, and then title. So title, I'm going to use char maybe 100 letters. Okay, that is by default. It can be option, and then credit. Credit. So credits, let's just say use a number. So we want to have like something like a 0.5 credits, and then we can have up to like a 99, 18.5 something. You know, some large courses, some long semester, like semester long course could have up to like a 15 credits hours. So I will just use 3, 1. So that will allow you to have up to 99.9 hours in credit hours. Okay. And also this is optional, so that we leave that alone. And then finally we have professor. Professor is actually the IID duplicated. Okay, so we are going to have the same data type and size as IID, but name can be different. And this is also required, so not no. All right, so now let's do constraint. The first one is the PK. So PK for class, primary key. So that will be course number and section number. Okay. Does it make sense? Course number, section number, both. Okay. And then we have one foreign key, FK. So there's the class. The foreign key is actually coming from, well, professor, right? So prof. Then say primary foreign key. Foreign key, which is professor. And then references. The name of the table was called professors. Okay. And this last constraint, we can finish that semicolon. Okay. And then we can add the junction table because junction table requires students. So we'll have to do student table first. Okay. So let's do next one. Create table students, which has student ID. Let's just use number, maybe 7 digits number. So you can see how many students you can have. Not now. So the basically 7 digits that allow you to have like a 9 million students. Okay. And then last name, char 45. So this by default is optional. First name, char 45 can be also optional. Major. So here we assume just student has only one major. Okay, but sometimes if a student have multiple majors, then this become multi-valued attributes. Then you need to single that out to make it a weak entity too. Right? So here major, let's say char 25 is also optional. And then birth date. Birth date is date. Okay, and it's also by default is optional. So don't confuse date, data time. Data time is data type for Microsoft, for SQL, for C#. But here we use date. Oracle date is actually also date and time all together. So it has date and also time inside. Okay, so then we need to have a constraint. For this one, we just have a constraint for primary key. So constraint PK STO, say primary key, and then let's say the primary key is SID. right? That's the only thing, right? Okay, so we finish that, semicolon. Finally, let's do the junction table. So let me move this up. Okay. So the junction table, create table. So what do we call the junction table? Which is between student and the classes. It's more like an enrollment, right? So we can take a enrollment. Okay. And then student ID. Remember that is the same thing as the student ID duplicated. So it should be number 7, according to first referential integrity rule. And the junction table, the foreign key is always required, not null. So now let's do course number and section number. So course number. So again, you can change names, but if you don't like type complete the course number as was in the primary and the primary key. So course number, remember what do we use for course number? We use char 8. Okay, so we'll have it duplicated here also. Char 8. Okay, no. And then we have a section. And the section was number 3, right? So it's duplicated from here. So we have to use the same data type size, not null. All right, so that is, that's all the columns. So now let's do primary key, foreign keys. Okay, so let's say primary key basically will consist of all foreign key columns. So let's say constraint, PK, enroll, let's say primary key. Primary key is SID, 1 column, course number, and then section. So just make sure that when you reference to primary key, foreign keys, the name of columns must be the name of the tape columns inside the table you are creating the constraint. So for example, if you change this to course, then you have to change this to course also. You see my mouse moving? So for example, if I say this is a course, not a course number, then you also have to change that, okay? You should be synchronized with your current table's column names, not with original primary key column names. Okay, so that is a primary key consisting of 3 columns. And now we can do constraints. So we have 2 constraints, remember? So one constraint is student ID coming from student. So FK, enroll, still, okay? Then foreign key, and that is SID, then references, students table. Like that. Then we have a second constraint, FK, enroll, and this one is foreign class, okay? Foreign key. And then I purposely make a mistake here, so can somebody point out what is wrong here? References, classes, semicolon, semicolon. So if you try to run this, you're going to get an error message. Can somebody point out why is this wrong?
There needs to be a parenthesis after classes.
If the parentheses after the classes, no. You have, this is a closing parenthesis here.
Okay.
Yeah, that's fine. Any other thought? Anybody?
Is it because you put section before course number?
Yeah, that's it. That's it. Because when you define primary key, the primary key was course number and the section number, right? So that it was original primary key. But now you're trying to duplicate that, but then you claim that this is the primary key. That start with section number and then course number. That will not be acceptable, okay? So the foreign key must be exactly the one, in the originally defined duplicated. Question? Yeah. Yeah. Okay, when you set a primary key here, say for example, student ID, I said this is not really necessary. This now is not necessary because by default, all primary keys will be not null. You don't have to, yeah, you don't have to say this not null because when you say there's a primary key, then all their columns must be not null. Okay, so you cannot have a primary key which has missing values. Okay, good question. Any other questions? Now, if there's no other questions, let's run this. I hope we do not have anything duplication, but if we do, then we are going to drop those tables. So let me try to run this first, okay? Run all of them, select all of them and run. Okay, I do have one problem here, which is when I do enrollment, what does it say? It says, oh, I did not make corrections here. See that? So there's error here. That's it. So this error I get. So basically, I need to change this to course first, and the section next. Okay. Now we can run it again. So create it. All right. All right, so basically, when you submit homework, of course, you need a relational model, and then from the relational model, I can tell whether your code is correct. Okay. All right, sorry for that. Any questions, anybody? Now, if there's no questions, I'm going to go over the PowerPoint I did last week and then make sure I clean up any unsolved issues. So I'm going to put this aside for now. And put this aside for now. So PowerPoint, that was for SQL. Okay, let me run the slideshow from beginning. We did that. Reviewed. We did that. Okay, so we talk about SQL programming language, and we talk about how to create table syntax. Okay, and then we're trying to do the 3 examples, but actually we do not have time to do all 3, so we did one. Actually, use your homework. Did 1 example. Okay. Referential integrity rule again. Field type and size for foreign key column must match the corresponding primary key column. Otherwise, if you don't follow the rule, you will not be able to run your SQL statements. Okay, you're going to get an error message. Okay, so now we are going to get into a little bit knowledge about the DBMS or Oracle in particular. Okay, so what is DBMS? DBMS, database management systems, right? So it basically is a program that allows us to create database, to secure database, and to manage database. Okay, so basically just remember the 3 functionalities: create, secure, and manage. Okay, and so the responsibility, if you want to look at the details, that would be what? So for example, how to organize data. So that means how to create a database, create tables, organize table structures, connecting primary key, foreign keys. So that's called data definition, data organization. Okay, and then data manipulation, that will be include retrieving data, create new records, delete the records, or modify existing records. That's data manipulation. And then, of course, we need to make sure you have security and integrity enforcement. So security, of course, is understand. So you do not want somebody who does not have privilege to mess up with your data, right? And the integrity is, say, if you want to have a piece of data, you want that data to be consistent throughout. So you do not want to have a, fragmented data, different kind of data for the same piece of information, right? So for example, student's major, you change major, and then that major should be changed for that student. So you should not have a second major for that student, if the student just have one major, and you change it, and then that change should be the one that should be stayed in the database. And then what else? Concurrency control. We'll talk about the concurrency control and atomicity in the next slide. So in general, database management, there's a couple of issues. So first one is data redundancy. We'll have one class, one week, talk about data redundancy and how do we solve that data redundancy problem. Okay, so if you have too many duplicated data items, it's not just a waste of resources, waste of storage to hold the store data. And essentially, the most difficult part is your database is going to be useless. The database is going to be useless. It's not operable. So you basically cannot change data, you cannot add records, you cannot insert the records. You're going to have a lot of trouble when you have data redundancy. Okay, so that is one typical issue with database design. And then data inconsistency, the same information I just said about one entity should appear the same in different places. So if you have duplication, data duplication, then that is another problem. So for example, if a student the major data has been duplicated, and then you change the ones and then don't change other places, then the student will have two different majors inside the database, right? And the data integrity, so data should be stored, should follow certain rules. For example, we have like a student grade. The grade must be either A, B, C, D, or F, right? You cannot have X, Y, Z as a grade, can you? So, but if you don't have, if you do not have certain rules to enforce that, then, users can just, make mistakes into anything into your database. Okay, arbitrary values, which may not be valid values, all right? So that data integrity typically will be enforced by some kind of a database rules or business rules. And atomicity transactions, so sometimes you have long transactions. For example, you want the data to be, say, copied from one place and then paste into another place. And then finally you want to save that. So it may have multiple actions to be performed. So so-called atomicity just means that a transaction must be either complete or not at all. Okay, so you do not want to leave a transaction partially finished, partially completed. So that will cause your data integrity issue. Okay, concurrency control is about so suppose two people trying to change same piece of data. Can you imagine that? So two or three people trying to change the same piece of data. So without concurrency control, then basically those people can override each other, right? So one person made a change, the second person changed it to something else, and then the change will never been finalized. So what so-called concurrency control is just make sure that each piece of data will have a lock, and then only one person can. So if the lock is released to you, then you can make changes, and other people have to wait for the lock to be released to make another change. Okay, so that is concurrency control. Security, you understand that, okay? All right, so for Oracle database connections, we talked about we can use SQL developer, but in general, if you're in the companies, they probably will use some kind of a formal SQL client, which consists of like a terminal device called PL Plus. It's like a terminal. You can only type one line at a time, and then you enter, and then get a response, and then you type another line, and then enter, you respond again. So basically, you will not have those kind of graphical user interfaces. You can select multiple commands and run, and you can copy and paste. You don't have that capabilities. So if that is the case, then you'll probably need to use so-called TNS names to build connections. And this is a TNS name. So first of all, you need to find out where the file is located. This file will be typically located, for example, in my case, It's located in, I installed this inside app folder, Oracle product 19, and then client. So I put it inside this place. Okay, inside that there's a network folder, and then inside network folder there's admin folder. Okay, and inside that I have a bunch of files. I have a listener file, we have the SQL file, and I have like a TNS names file. So this is the file that will have all your connection parameters, or your connection descriptions. Okay, so let me show you what the description typically looks like. The description will look like this. So for example, for ecourse.org, we just made connection to. You don't have like some kind of description like that. First of all, you will specify that it's going to use TCP/IP protocol to make a connection, and this is a host name. Remember that we need 3 parameters, right? Host name, and the port number, and also service name. Okay, so all the 3 parameters will be embedded in this description. So you can have one or more of these kind of descriptions. So for example, you can have a CBA 12C, a CBA 11G, and list one by one. So that basically, you can have put multiple of this kind of description inside this one file, DNS names. And after that, the next time when you make connections, you then just specify ecourse.org or CBA 11G or whatever, and then your username password to make connections. You do not have to provide all these kind of parameters again. So like a host name, port number, service name, you don't have to reference to those anymore. Okay, so that is basically a basic approach, the most fundamental approach to make connections to Oracle. So this is what we did in the class. So basically, we need to specify username, password, and then we need to specify the host name, port number, and that, right? But if we choose TNS, so let me show you whether I have the TNS here. So I think I should have. So here, if I make another connection here, okay? And then let's say if I choose like a non-default, use like a TNS one. So then immediately I see that I have many connections. So CBA 11G, CBA 12C, all those have been, so all those are inside Oracle client, the file I just made, okay? So for example, everyone selects connect to 12C, and then I just need to provide username and password. That's the only thing I need. Does it make sense? Okay, so that is about database connection. Now let me continue from the current slide. Okay. All right, so we already did how to create a new user, do we? So we can create a new user, but of course you do not have a privilege to create a new user. But just know the syntax: create a user, username, password, identified by a new password, and then we learn how to change the password. And if you want to drop a user, just simply drop user the username. Okay, and of course you do not have a privilege to do that either. Okay, so for example, if I'm going to do it, I will do something like this here. Cancel that. I don't need that. Okay, so if I do that, I will say drop user, and then say Scott. Okay, and in case if Scott has a lot of data inside, I want get rid of everything in his account, even though his table, his constraints may be tied to other users. I will just say cascade, and then that will basically just get rid of that account cleanly. Does not matter whether the account has anything referenced by other users, used by other users. Okay, so that is how to drop user account. Okay, good. And then just let you know that if you're trying to log on to Oracle after you tried 5 times, your account may be unlocked. Your account might be unlocked, so you cannot log in anymore. It's just a security feature. So in that case, if I want to get a locked user back, so I will do alter user. Okay, so for example, Scott. Okay, and then you can change the password, right? So that's what we learned the previous class. Identified by, for example, Tiger. Okay, and then account unlock. So that basically will unlock the user. Okay. So for quite a few users, you had a problem with that. So I did that, just basically unlock you. Okay. But of course, you need to have a privilege to do that. All right. Not necessarily DBA, but it's just make sure that you have a privilege to manage other users. That is some kind of privilege you need to get. All right, so now let's move on. So we handled that. And then we did this using implemented database. So first of all, we learned how to create new tables, and we learned how to delete tables, did we? All right. And now let's learn how we're going to list all the tables you have. List all the tables you have, okay? So we are going to use some kind of a system table or called meta tables. That's called a user underscore tables. That's the name of a table. That's the name of a table. That table is not created by you, by any user. It's actually managed, created automatically by the system, by Oracle system. So every time when you create a new table, then the Oracle is going to add information about your table into this table. Kind of confusing, right? Table about tables, okay? So this is the meta table. So let's try and look at the table first, okay? So let's see. At this point, if you have Oracle SQL Developer open, then you can just follow me. First of all, I'm going to describe, say how the table, what are the columns of the table. So describe user underscore tables, okay? So basically, you do not need a semicolon. The semicolon is not necessary, but it doesn't matter, you can put it, okay? So describe, and then you can run that. So this will give you the list of columns for the table that you're trying to look up. Okay, so this table, for example, has a bunch of those columns, like table name, table space name, customer name, IoT, status, percent free, percent used. So data, you can allocate a certain amount of space to the table, and then this can manage how much space has been used and how much is free. Okay, so let's try that again. So suppose we already have a table called enrollment, right? So let's describe that. Enrollment. Okay, on my column. Let's run that. So the enrollment table we created has 3 columns: student ID, course number, section, not type, right? So basically that give you the table structure like that. Is that clear? That's how you describe any table. All right, so let's go back to the original one. So run this one again. So let's say with this, the meta table has so many columns. So which column will give us all the table names? So basically, this table name column will give us that, right? So if I'm going to just trying to get that column data, just get this column data from this user underscore tables table, then it will give me all the name of the columns. So I'm going to say select, okay, table underscore name. It's not case sensitive, okay, even though inside here is all capital, but you can just use small letters. All names, table names, column names are not case sensitive, including keywords like select, like drop, create, they are not case sensitive. So I will say select, and then say from, the name of table is user underscore tables, okay? So what does this do? Let's just simply say retrieve table name column from user underscore tables. So this is a table, and then you have a name of column called table name, and then you you just retrieve that column from this table. Okay, so this is just show you this is a way to make comment. Okay, so if you have something you do not want to show, but you want to have a note, just dash. Okay, dash. So in C# use // right? Okay, here just dash. So anything after that will not be executed. Okay, so let's run that. All right, so it tells me that I have this kind of tables. Okay, appointments, visit sign, vital signs. Did we do that? We did that last class, did we? This is vital signs appointments. Yeah, we did that. Okay, so today we did professors, classes, student, and enrollment. Okay, that's good. So we have the 10 tables. So this basically this give you all the table names. So now if you say I forgot visit sign, what do you see inside the visit sign? So I'm going to say describe the vital sign. So describe vital signs. All right, and then run it. So it will give me that the vital sign has those two columns: vital sign number, with the name, a vital sign value, and a visit that is a foreign key. Make sense? So that help you to describe table structure. But at this point, the vital sign does not have any data. If you do want to look at the data, this is a simple command. So just simply select star. That means all the columns from vital signs. Okay, semicolon. So star for all columns. If you just want to look up one column, just put the column name in there. If you have two columns, then the column, comma, another column. Okay. So this, we are going to learn data manipulation language after the first exam. So this is just a simple ones, help you to look up some simple information. So here, if you run it, you should have no data because we do not put any data into the table yet. We have not done any data yet. Okay. All right. So this is how we look up a table structure, list of tables, and also the table content. So this is looking at table content. Okay. So let me go back to PowerPoint. So let's run it again from the current slide. So next one is to look up the structure of a particular table. We already did that. Okay. So that's number 2, number 3, number 4 is done. So how do we look up constraints? Constraints. Okay. Sometimes when you're trying to create a table, if a constraint name is already used and then trying to reuse the same constraint name, then you're going to get an error message. Constraint is kind of database objects, just kind of attached tables, but most find attached tables, but you can consider constraints as separate database objects. Okay, just like users, tables, constraints. Constraints maybe consider third type of database objects. So how do we look up constraints? So we're going to use user_constraints meta table. Okay, so let's do that. So describe. Okay, user_constraints. So again, every time when you create a new constraints, this table will record all the information about your constraints. So what are information you have? You have information like owner, who owns the constraint, basically just a username. And then what is name of constraint, and what is type of constraint, and which table has the constraint. Okay, and plus there's some other things we may not be concerned for now. So just constraint name, constraint type, and then maybe table name. Those are the 3 things we need. All right. So I'm going to look up those 3 columns. Okay, look up table constraint name. Okay, constraint type. Constraint type. And then table name. So we're basically looking up, retrieve the 3 columns from user_constraints. The 3 columns, okay? So this is the name of a meta table for the user_constraints, and those are the 3 columns. Let's see, they were listed here, right? So you can use other things too. And now if we run that, that'll give you all the constraints I have. And in your case, you should list all the constraints you have. Okay, so let me run that. All right, so I have quite a few here. So first one, this is PK enroll CRS. You understand that as a foreign key, right? So this is reference type. And then the table has the foreign key is enrollment. Okay, and then student, and also primary key here. And then C here, this table is this foreign key, this type is C. C means check constraints. But you see that there's something strange here. You see that? We never named those constraints. So what are they? They are the constraints created automatically by the system. So when you say not null, those will become a constraint. So since you did not name those constraints, so system will provide artificial name for it. Make sense? So basically, for example, this tell you that the enrollment has one constraint, named as this, is check constraint. Okay. So there are quite a few of those. So now you understand that if you don't name a constraint, system will automatically create a name for you. So if you're a DBA, you will not like this because you don't know what is this, right? You don't know what are these names. But if I give you a constraint like this, PK visit, then you know that is this foreign key and it's a reference type and it's attached to this table. So in case I need to maintain the data, so I may need to temporarily remove the constraint so that I can copy data, I can insert data so that I don't have to deal with so many error messages. So the DBA would like to have a constraint be named. But those things, they are not named because they are simple ones like not null thing. So they are simply just like a check constraints. And so did we do this? Check age, did we do that? So age must be greater than 0, right? So that was a check constraint and we name it. So now you can see that name is here. Okay, so what about columns? How do I know that the constraint tie which columns? This one give you only tables, the table have those constraints, but I don't know which columns are involved in those constraints. So to find that, you need to use another meta table is called user underscore constraints and underscore columns. So this table has information about which constraint is tied to which columns. Okay, so let me describe that, then we'll look on that. So describe user underscore cons and underscore columns. Okay. So that will give us a couple of columns, which will show, it does not have many columns here. We show column name, constraint name, and table name, and a column name, and the position. So if you have multiple columns, there's column in which position. Okay, so let's say I want to just get a constraint name, table name, and a column name, the 3 columns. Okay, so that way we'll be able to tell which constraint is tied to which columns. So select constraint name. Okay, and then table name, and then column name. From so it does not matter where do you start, where do you put the next lines. Basically, every statement ends with semicolons, so you can split one row into multiple rows, or you can just do everything in 1 row or 2 rows. Does not matter. User underscore cons, and then columns. Semicolon. Okay, so trying to get these 3 columns data. These 3 columns data from this from users underscore counts, this columns meta table. Okay. There we go. So now you see that the first one, foreign key, enroll class is enrollment, and then that column is section. Okay. And also this foreign key, and then course number. So basically this tells you, this foreign key constraint has 2 columns to be attached. And then this foreign key has student ID, and this foreign key enroll. Okay, as those 2 columns. So basically it tells you which column. So this is the check constraint is to section number. Probably section number is not null. This course number is not null. Okay, does it make sense? It will give you which column, which table, and which column, and involved in which constraint. Okay. Any questions? Pretty simple, right? So now let's move on. Let's see. Now let's try to learn how to modify your existing table. So that is typically say if you already have data inside a table, you do not want to delete, drop them, and recreate them because that would be disaster, right? So you want, say, for example, dynamically add more columns or change columns. If the size is too small, you want to expand it, okay? Or if you need additional columns, then you want to add it. So this is how you, this is the syntax you want to do. So basically, you just say auto table, the name of table. Okay, and then beside and underneath that, you can add a column and a column definition. So you basically just do the same thing as you create a new column. Okay, like say some kind of a name column, data type, and whether it's not null or not. Okay, just list columns one by one, put inside the parentheses. You can also add constraints, just like what we did with constraints. So for example, add a new constraint and then name of constraint, constraint type, and then what is actual constraint. Okay, and then you can also drop a column, then name of column. That's only thing we need. Okay, or drop. You can also drop a constraint, the name of constraint. Okay, and you can also just alter the column. So just say the name you do not want to drop. You do not want to remove the column or to add a new one, but just alter the column. Just change the column. So for example, change column size. Okay. Then you can do that. So I'm going to use this to practice a couple of examples. Okay, so let's see whether I have an example here. No, we do not use this one. All right, so I'm going to use just create one based on what we have. Okay. Okay. So now let me try to describe table students. Describe table students. Okay. So that student table currently have student ID, last name, first name, major, and a birth date, right? So first thing I want to do is add a meet date to students table. To students, okay? Add a new column to students. So alter table students. Assuming that you already have table students, okay? If you don't, then this will not work. Make sense? Okay. And then remember this time, you can use any one of those. Okay, just do not use all of them. Just use, say, I will use add a column this time. Okay. So this pipeline just means choice. You can choose this one or this one or this one, something like that. Okay. So I'm going to do add columns. Add column. Okay. So which column we want to add? So we are going to put that inside the parentheses here. Let's say we'll just do add meet date. Add meet date. And that is data time, right? Data time. Okay. Is all the meet date required? Then say not null. Okay. And then if you have more columns to add, then comma, and then second column for the column, separate them. Just like you create a new table. So I'm going to stop here. Okay. Maybe you do not need this. You do not need this one. You do not need this parentheses. So add, I don't know where this. Hold on, let me run this. I think there's something wrong here. So here it says L table is add a column admitted not null, so what's an invalid identifier. So basically is it will give me that kind of error. Let me run this one. Add a column, or maybe we do not need to add the name of column there. So it's still wrong. So actually we just do this. Let's do this. Add that. Okay. So add. Okay, so that will add basically column names. Let's run that. Okay, so this table is added altered. So actually you do not need to add a column there. So the syntax has kind of a okay, so you need, this is actually column name. So add and then column name. So let me try to do it again, okay? So just make sure that it's not wrong. So let's say, let's look at the enrollment table. Describe enrollment. Okay. The enrollment table currently have student ID, course number, section. So now let's try and add another column to enrollment, which is student grade. Okay, auto table, enrollment. Okay, and then say add, and then parentheses, and then grade. Okay, so grade is like a char, right? So we'll say char, 2 letters, maybe just 1 letter. Let's just use 1 letter. Okay, for now, so char. Okay, so grade is required or optional? This is optional, of course. Okay, so we'll do that. Let's add one more column. So this time let's say add grade, and also for enrollment, let's just say enrollment date. Okay, enroll date. Enroll date, that's a date. Okay, so let's say we add 2 columns this time. Okay, so let me say this is add 2 columns to enrollment. Okay, and run it. So those 2 columns will be added without trouble. So now let's describe enrollment again. So you should see that you have more columns added. So now you have grade and also enrollment date here. Make sense? Okay, next, let's try and add, so you can add columns like this for all of the tables if you need. So now let's try to add constraints, okay? So for example, the student table, let's describe the student table again. Student table. In the student table, we have major, admit date, last name, all that, right? So let's just try and add a constraint that the constraint will say that the birth date must be before admit date. So that's basically rule, right? So basically you have to enforce that nobody can just type incorrect admit date, okay? So I will do auto table. The name of the table is students, okay? And then we add again, so parentheses. So constraint, the name of constraint, which is check, say check dates, okay? Check admit date, admit date, okay? So what is actual constraint? We'll say put a check, and then put parentheses first, because you may just, there are too many parentheses, you may confuse. Okay, so I will just stop here, close that whole parentheses, and assign my column. So now what is actual constraint? The constraint is admit date is master after birth date. See that? See the birth date and admit date. So this time we add constraints. Okay, run it. So now this constraint is this new constraint added. Let's do it again. So this time, let's say I want to add a constraint to grade. For enrollment grade, the grade must be either A or B or C or D or F. Okay, only those 5 possible values are allowed. So I'm going to describe enrollment again. Okay, describe enrollment, and then let's say I want to add a constraint to enrollment. Add another auto table enrollment. Okay, and then add, so parentheses. Okay, add a constraint. So the constraint I need is just ensure that is check grades. Okay, check grades, and then we check, and then parentheses. Finish that first, and then close the whole thing, and then semicolon. Okay, so put a parenthesis, put inside the parenthesis check constraint, which is we're going to check. Okay, so grade. Remember the column name is grade. Must be in the list of possible values. And now we create the list inside this parenthesis. Okay, inside this parenthesis. So there are so many parentheses. So the first one is A, comma. Second possible value is B, comma. And the third possible value is C, and then D, and F. Now there's a single quote F. So this is how to create a list of possible values. Okay, because we are using text, right? Text must be put inside a single quote. The data inside a single quote are case sensitive. So this is not the same as small letter A. This is not the same as small letter B. So these are case sensitive. Okay, and then to create the list just use inside the parentheses, and then separated. The items are separated by commas. Okay, so if you want to make sure the state is one of the 50 states, you probably want to do the same thing, right? When a state in, say, Ohio, New Jersey, New York, put this list. All right, and there we go. So this is, so just make sure that you have too many parentheses. You want to, when you put the opening ones, just close it first, okay? Before you move on to the actual content. So let's run that. Good. So now table has been changed. Enrollment has been changed. Okay. So we have, let me see. So we learned how to add columns and add constraints. So to drop, then you basically just specify, drop which column you want to drop and drop which constraint. So we're going to do a few more next class. So let me see how many small slides we have here. So this is fine. We did that. So we are going to have creating sequence, drop views, script views, synonyms. Oh, too much. Okay, and then create the database links. That's it, 3 more slides. So next class, we should have a little bit more time to move on to a new PowerPoint slides. And then that will be for this class. Does anybody have questions? Yeah. The exam will be formatted as you're going to have a module percent, like 60, 70% multiple choice questions. You can do online. Just make sure you have only one time try. There's no multiple choice, one time only, okay? And then you're also going to have like a 30 to 40% questions. You have to use data modeler or writing code, like what you did with homework. Okay, so basically that would be 30 to 40%. Okay. For this multiple choice questions, you have to do finish within the time frame. For hands-on questions, you probably I need to think about how we do that. So it depends on the nature of the question I write. So for example, the question can be done quickly, you probably can do in class time. But if not, then I can just give you extended time. Okay.
I have a question.
All right. Yeah.
Is what we learned today and tomorrow also going to be on the first exam, or is that going to be on the second exam?
What we learned today will be on the first exam too, yes. So your homework will be due next Monday, and then we'll go over your homework and answer your questions. And then that will be, what we do today will be on the first exam.
Okay, thank you.
Yeah. Any other questions?